Today is a great day to learn about statistics and psychology, and we are going to go over some of the stats information that you're going to want to know for the AP Psych exam and for the exam for Unit 1. So let's get started. There are two videos in this slideshow. They are linked in the slides that are posted to Google Classroom, so I would expect that you just watch them there. I'm not going to sit here while you watch them. So the first is on why stats can be misleading. It's really important to be statistically informed and to understand statistics, right? Especially in the day and age in which stats are thrown at us every day. So, right, we're in the midst of the COVID pandemic, and every day we are hearing stats about positive cases, how many cases there are, tests, more tests, and whether your political leanings are left or right. Both sides are giving information about what's going on. We want to be able to dissect that and understand that. So statistical understanding of data is important because it helps you understand research, and a huge percentage of this class is going to be research. It helps you reason, it helps you make decisions, it helps you understand what's going on, and it helps you look at the news or look at posts that people are making on different social media sites and think critically about them. Like, is this a legit statistic or is this bogus? And statistical literacy is just a lifelong skill that you are definitely going to want to have in your back pocket. So the first thing that I want to talk about is the term descriptive statistics. So here's what descriptive statistics do. They give you information about a group of numbers, or it gives you information about the qualities of the group. So if a term like descriptive statistics shows up on the exam, either the unit exam or the AP Psych exam in May, you don't want to say descriptive statistics are statistics that describe, because right, that's just repeating the term. So I'll say describe here because it's describing qualities about the groups. It's measuring the groups. It gives you information about the groups. So the two types of descriptive statistics I want to mention are, first of all, a histogram. A histogram is simply just a fancy way to say bar graph, essentially. So a couple of years ago, the term histogram showed up on the AP exam, and kids were like, what is what? It's a bar graph, okay? So the y-axis is going to be the dependent variable. The x-axis is going to be the independent variable, and being able to understand that is important. Being able to remember that is important. I have the mnemonic device that I use is like, it seems backwards to me. So instead of XY for how it would go, it's YX. The other thing that you want to know, make sure you understand, is what is a measure of central tendency. Measures of central tendency is just a really fancy way to say mean, median, and mode, which you've been talking about since you were in elementary school. The mean is the average. You take all of the numbers up, you add them all up, you divide them by the total number of numbers. Okay, it's an average. The mode is the number that occurs most frequently, the number that appears the most in the distribution. The median is the exact middle. You line up the numbers from lowest or the smallest number to the largest number, and then you find the exact middle. If the median is, if there is a question about, right, if there's two numbers, or if there's you add them up and then divide them by the two. So if there's an even number of numbers in the median. So the big thing to remember about the average, and arithmetic average, is that when the data is lopsided or when there's skewed data, we need to think of other measures. So if we would do something like income per family, if there are huge outliers in a school or huge outliers in a community, if you think about what would happen if Bill Gates moved into Kimberly, Wisconsin, right, the average income per household would skyrocket, even though your family's income hasn't changed at all. It's just that the average will have changed because there's now an outlier. When we say data is skewed, we mean that there are values or there's groupings of numbers that mess with the data. So when we say a set is negatively skewed, it doesn't mean bad. Remember, negative in psychology is not bad. A negative skew mean that most of the numbers or most of the scores tend to go towards the negative number line, right? They go, which means that the scores are clustering around a high point, which means if this was our test scores, it would mean that everybody did really, really well. This would probably mean if you're a psychometrician or if you're a person who makes tests for a living, that this test was too easy. On the opposite end of the direction, when the skew goes towards the positive direction, towards the positive number line, and the cluster is to the left of the graph, it means that all of the scores are low. So it would mean that on an exam, everybody did poorly. This also means that the test was probably a bad test. It was probably too difficult, or the teacher didn't teach the material that they should have. When a test has a normal skew or a normal curve or no skew, it looks like a bell curve. We call this the normal curve, and distributions of tests, distributions of things like weight or intelligence or height or ACT scores or SAT scores, right? Anytime we have a big set of data, they tend to cluster in what we call a normal curve. It tends to have no skew, and it tends to form almost a perfect bell-shaped curve. So when we talk about a bell curve or a normal curve, we're going to be moving into talking about measures of variation. A measure of variation is how different are scores, or how much do scores vary. So the range is the difference between the highest score and the lowest score. So a range, if the high score on an exam was 50 out of 50, then the low score was 25 out of 50, the range would be 25. Okay. Then we also have what we call a standard deviation. A standard deviation is a calculation. It's a mathematical calculation. You do not need to know how to do the mathematical calculation, but you need to understand that a standard deviation is a way that we look at how scores cluster around an average. So it's a way of looking on average, how average is a score. There's a video here. Watch it, and then you can switch to the next slide. But a standard deviation is going to take anything, intelligence, weight, height, ACT scores, like any kind of mass distribution of numbers, and it's going to try to make sense of it, and it's almost always going to fall into a perfect bell curve. Here is what standard deviation tells us. How average on average are you? Okay, so when we have an average, the average is going to be right here, the middle score, the middle in the set of data. Everything that falls above is going to be higher than average. Everything that goes to the left is going to be lower than average. When we talk about one standard deviation is going to be right here in the purpley bluish color. When someone says, or when you see a piece of information that says a person is one standard deviation from the mean, it means that they are within this range. This range, 34 plus 34 is 68. So 68% of people are within one standard deviation from the mean for intelligence, right? Intelligence, or the average score in a normal curve always is 100. Each of these lines here, so this is average, this marks 15 points, and that's just the mathematical calculation. It's always 15 points. This is 15 points, so here's average 100, here's 115, here's 130, here's 145. Here's 100, here's 100 minus 15, which is 85, right here. 85 minus 15, 70, right? So that would be right here. When we talk about two standard deviations is going to take the blue and it's going to add the red. So here's one standard deviation above the mean. Oops. Here's 2 standard deviations above the mean. So 34 plus 14, right? That's 2 standard deviations above. When you talk about 2 standard deviations below, 34 plus 14, 2 standard deviations below. So 14 plus 34 plus 34 plus 14 is going to be 95% of the scores. 95% of people are going to score within 2 standard deviations from the mean on whatever test you happen to give. So if you take 34 plus 13, and then you talk about 1 additional standard deviation, so that's going to be the green bars. 34 plus 13 plus 2 is going to be 1 standard deviation below, 2 standard deviations below, 3 standard deviations below. You are going to be looking at 99% of people. 99% of people fall within 3 standard deviations of average. So if it's height, right, you have your crazy tall person who's like 7 feet something, that's going to be over here. You have your very short people, that would be over here. Most of us, though, right, fall within the average. I think it's like 5'5" for women and 5'8" for men or something like that, right? Most of us are really average. Inferential statistics are a type of statistics. So descriptive statistics describe, give us information, show us things. Inferential statistics allow us to make predictions, allow us to infer, allow us to judge whether or not something is true of all people. The important term that we want to remember for inferential statistics is the idea of something being statistically significant. So statistical significance occurs when the data is not a fluke. It's not due to chance. It's not happenstance. The independent variable is most likely causing the dependent variable to happen. The threshold that we need is 5%. And that's right, 5% fluke, chance of fluke. I don't know, right, if I take a medication and there's a 5% chance that it could hurt me, or if there's a 5% chance that a surgical procedure could kill me, I'm going to think twice about it. So the lower the p-value, the better. The threshold is 5%, but the less the probability, the less fluke chance, the lower the probability, the better. Anytime a probability is 5% or higher that something was a fluke or that the independent variable didn't cause the dependent variable, we are going to say that you want to redo that, you want to fix, want to go back, check your study, fix it, go back. Okay, that is, that's p-value. Okay, it also helps you reject the null hypothesis. So ethics in psychology, real quickly. You, when you're done with your research, you're looking at your data, you're calculating all these data, everything. You also want to make sure that you conducted your study in an ethical way. So before you actually do research, you're going to write up a proposal. You're going to give it to what's called an institutional review board. The IRB is going to judge whether or not your study falls under the following categories. Do no harm. This is both psychological and physical. You cannot hurt people in a psychological study. You cannot, right? You cannot physically or mentally harm them. Debriefing means you tell afterwards. You tell afterwards. You have to indicate that it's after. You debrief after a study is done. You tell what the findings were and what happened. Informed consent happens before. You need to highlight that it's beforehand. You give people information about the study. You tell them what you're researching. You have them sign off on it, and you also tell them that they can leave the study at any time. You should not use deception, or if you use deception, it should be minimal. So you can't overtly lie to a person and say this is what you're studying when it's not really what you're studying. You want to maintain confidentiality, meaning that you cannot blurb about people what you found, you cannot give people's names, you cannot put out people's social security numbers, you can't post, right? You have to maintain subjects' confidentiality. And also, people cannot be forced to participate in a study. You cannot say your grade is attached to participation in this study. And you have to let them leave the study at any time if they want to. So you cannot make